Well, this is it. If you're here listening to this talk and you stay through, it will be the end of the conference for you. So next up, we have Deepa, Kalani, and Ramiro, Salas from VMware, and they will be talking about VMware Tanzu Service Mesh from the developer's perspective. So off to them now.
Thank you. Appreciate that. I'm Ramiro. I work at VMware, and I'm focusing on technology across the stack, primarily on networking and security.
I'm Deepa, and I also work for VMware, and I'm a technical product manager on the Tanzu Service Mesh team.
Great. So let's start our screen share, and give me 1 second here. Okay. So our talk today is VMware Tanzu Service Mesh from the developer perspective. So first of all, thank you for attending our talk. What Deepa and I are going to cover today is we're going to start with a quick refresher on Service Mesh. I think this should be a pretty common pattern these days. You guys have heard quite a bit of that during the show, and it should, be definitely something more known than it used to be just a couple of years ago. Then we're going to cover TSM, as we call it, Tanzu Service Mesh, as a product per se. We're going to dive into what it does, what's different about this product versus other implementations out there. And then how can developers leverage some of the new constructs that TSM provides, specifically things around global namespaces, which is something that we're going to be defining and describing during the talk. How can also developers or how can TSM be used as a part of a larger platform? Ultimately, none of these products are supposed to operate in the vacuum. All of them are always part of an ecosystem. How can you actually use it in a way that adds value to you, in a way that adds speed to you? And finally, you're going to see a full feature demo that will include all the characteristics of this product, and you can see what you can actually do with it. Of course, we always have to start with the traditional disclaimers. There's a number of things here that you're going to see that may never happen. Some of things are under construction. Some other ones may change substantially. Some other ones may burn your computer, etc. So you never know. However, what's important to understand is that we, as product teams, we do care deeply about your feedback. So we want to hear from you. We want to understand if we're actually solving the right use cases that you want us to solve. We want to understand if we're addressing all the things, if you have suggestions for us. And if you want to try our products, please reach out to your friendly VMware SE that will be happy to put us in contact and being able to let you try this for yourself. So let's start with some basics. There's a couple of talks that actually happened yesterday that are very, very good talks, actually. And here are the links. And I would encourage you, if you want to know more about Service Mesh in general as a technology and the difference between Service Mesh and other forms of technology and other alternatives, you please go ahead and look at these tracks. They're actually very good. And they will give you a lot more background on that than what we're going to cover here as a refresher. So first and foremost, on the Service Mesh side, I want to emphasize that Service Mesh needs to be seen primarily as an application connectivity pattern. It's essentially a technology. It's a way for services to be able to communicate with each other or other resources. Don't think in general in terms of a product. I mean, one thing that I've noticed by talking to people quite a bit about Service Mesh is that people tend to identify Service Mesh with a product. They either judge the technology based on what they like about the product or what they don't like about the product. Think about it more as a pattern, as a way of doing things, as an abstraction more than anything else. Don't judge necessarily the pattern or the technology based on what characteristics you like or you don't like about some implementations in the market, right? Different vendors, open source or not, right? So that I think is an important aspect. Ultimately, this pattern, the goal of this pattern is to help the service decouple from having to know about the network. Ultimately, that is the core of the value. If you really, get rid of everything else that the Service Mesh does for you, which is a lot of things. This is the most important thing about a Service Mesh. It allows you as a developer that are working on a service not to have to think about the complexities of the network. If you want to talk to a service, you basically call the service, right? Use that service. You don't care if that service is essentially on a different network on a different VXLAN, is supported by a different kind of container networking plugin, or is, for that matter, in a completely different cloud. This is one of the things that can be abstracted from you. So it adds the capability for you not to care. And you're going to see this as a recurring theme talk is the capability that you're now gaining as a developer of just focusing on the things that matter to you. A service mesh adds essentially software awareness to an otherwise agnostic stack. TCP/IP per se, if you look at it as a networking stack properly, doesn't really know what's consuming it, doesn't care about the applications that are running and using its services. TCP/IP knows about packets, it knows about sockets, window sizes, congestion controls, headers, payloads. That's the sort of thing that TCP/IP understands. It doesn't really care if you're a device or you're different operating systems or anything like that. Now, there's been add more intelligent protocol layers on top of TCP/IP, such as gRPC, for example, or RSocket that we've heard quite a bit during this conference, that are really trying to add that awareness layer on top of the networking stack. But like in most things, there's always a trade-off, right? You have to use them, you have to know them, you have to leverage them, you have to consume them as libraries or consume them as frameworks or anything like that. In the service mesh model, primarily, that capability is really offload 100% to the mesh. That is the primary concept behind this that you're going to gain as a capability. Now, service mesh can provide you with a lot of features and a lot of functionality, right? I mean, a lot of this is being covered in different talks: mutual TLS, including server rotations, service discovery, advanced telemetry, fault injections and retries, weighted routing for AV deployments, circuit breakers. Of the several years that we back at Pivotal talked to customers, mutual TLS actually, or for that matter, encryption and authenticated connections were by far the most important feature that people always wanted to hear about. And they wanted a technology, namely a service mesh in this case, to give you seamlessly that capability. And that includes server rotations, which is extremely important in environments. You want to create that ephemerality around the CAs and the certs that are generated. Now, obviously, you have to, if you want to consume these benefits, you're going to use these services, these capabilities. There's not too many ways around this, right? You can either add them directly in your application, right? You can code them yourself. You can say add service discovery, add observability, add connectivity directly in your app, or you can rely on the framework for it. But in both cases, they're essentially part of your app container, right? So you have to use them. You have to understand them. This is the library approach. This is the Spring approach. There's other frameworks for other languages as well that adds a lot of this capability. Very powerful, very commonly used, and it continued to evolve, and it's a very legitimate pattern, as you already have seen during the conference. There is, however, other set of use cases in which case you don't want to have to do nothing to do at all with those components. You want them to have a separate life cycle. You want them to have a separate evolution and upgradability pattern. In that case, you leverage what's called a sidecar. In a sidecar model, the app container is completely unaware of how the traffic is being handled. In fact, it's being lied to, technically, in most cases, right? The app container, its traffic is transparently redirected to the proxy in many cases. And the proxy deals with all that complexity behind scenes. And there's more and more features and capability that keep being added to the proxy. The advantage, again, of this model is essentially not having to care about any of these complexities of the network. If you do have to care, then that's a different approach that you have to follow, right? It's not for everything. There's always a trade-off in the technologies that you're using or choosing. So this talk, as we mentioned before, is Tanzu Service Mesh for developers, right? So what developers, first of all, what types of developers? As you know, there are many, many types of developers. We're focusing primarily on what we call corporate developers, right, today. People focusing on cloud-native apps, people focusing on refactoring monoliths, for example, or working across different clouds is becoming a very common pattern right now to see requirements of having multiple cloud vendors, right, within the same enterprise. If you're developing, say, software for FPGAs or avionics controls or anything like that, this is not for you at the moment. Now, having spent a lot of years in networking, I would venture to say that some form of this, some form of service mesh or software awareness added to the IP stack is eventually going to trickle into everything. I'm fairly certain that many future focus of technology will see some of this in one way or another across the entire software development spectrum. Now, these developers, corporate developers, have different concerns, right? You have the cube cuddle apply type developer, as we like to call it here. Essentially, if you're a Kubernetes developer, you do require and want to have complete control of your environment. You want to understand the interactions between all your services. Typically, you're working on either a polyglot app or you're working on definitely a microservice type app. You want to know all the interactions. If you're developing an application that has a front end, middleware, and back end, you need to define your policy as well. You need to make sure that the front end cannot communicate to the database, right? That just the middleware can connect to the database, and so on. You want to declare all those things and be explicit about it, and in a pure DevOps fashion, be ready to own it all the way. Be ready to operate that environment as well, right? That is one set of concerns. Not everybody has those concerns, but you're starting to see an increasing amount of developers really working in that direction. There are also the other side of the house, which is the CF push type developer. It's a very popular pattern that we have seen for years now in the enterprise, growing very fast, which is the type of developer that embraces the Cloud Foundry haiku, right? Which is, here's my code, run it on the cloud, I do not care how, right? So that type of developer primarily uses a PaaS, either Cloud Foundry, Tanzu Application Service, or another form of PaaS. And it tends to abstract even further via additional frameworks such as Spring. The service mesh needs to be able to help all of these types of development models. It needs to be transparent, it needs to get out of the way, and it needs to add value to all those particular models. There's also another type of development model that we're starting to see trickling into the enterprise right now, which is sort of a hybrid model, right? In which essentially you see people that do care about their business logic, they do focus a lot on the business logic, but they have specific requirements that are cloud related, right? Say your company signed an ELA with Microsoft, so you do need to use 100% Microsoft cloud products, right? So now you need to understand Azure, you need to understand the APIs, you need to understand the services, you need to understand all those things. Or you're multi-cloud and you have, now the requirement to use something like Amazon SQS, for example, right? So those are more specific constraints that are given to you as a developer, and you need to work with those, right? But you also want to be kind of agnostic of the development model. For that, you have Vue frameworks that are starting to come up, things like Knative as well, functions as a service. Knative is great in the sense that it also leverages the service mesh very naturally via the virtual service constructs. It just consumes that naturally, and it offloads a lot of that functionality directly to the mesh, right? There's some cloud-specific services that are coming up, et cetera. So the net of it is that the service mesh needs to be able to support all sort of development use cases. And the more we support, the better, right? And it needs to be transparent. It needs to be out of the way. So as a pattern, as a technology. So specifically about Tanzu Service Mesh, what's so special about this product in particular? What's so unique? What I find personally interesting about this product is the approach that VMware took to Service Mesh. The vision that VMware has is to deliver an enterprise class service mesh. And I know enterprise class is probably one of the most overloaded terms in the industry right now, total buzzword. But in practicality, VMware takes that very literally. Enterprise class means essentially just deliver on something that the enterprise care about. If you see here, you see discovery, visibility, control, security. Those are functionality aspects that you want to deliver, that the IT personnel, from developers to operators, care about having available and having at their disposal. But ultimately, as an enterprise, what you really do care about is about users, services, and data. If you're a CFO, you don't really care about containers. You don't really care about VMs or any of those things, but you do care a lot about your data, a lot about who can access under what situations your data, about the users that access your data, about the services and availability of those services for all sort of situations. And increasingly, IT people is focusing a lot on a multi-cloud and multi-abstraction model, where you have Kubernetes coming up strongly in the enterprise, but you also have public clouds coming strongly, either with or without Kubernetes. You have VMs, you have software as a service components, you have serverless, you have any number of new things. So you care about creating this sort of abstractions between them so you can be free to swap, to switch, to leverage things whenever you need to. So that is the enterprise class vision. It's really focusing on the things that matters to the enterprise first and foremost. Now, having multiple cloud environments are great, but they tend to become siloed. I mean, each one of them end up with their own tool sets, right? And the different ways of doing things. You have Kubernetes, you have public clouds, you have monoliths, and all of them are perfectly fine. There's nothing wrong with any of these technologies in general. But you do tend to, develop your own best practices around each one of these elements. So Tanzu Service Mesh as a product is really striving to eliminate that fragmentation and get you one step closer to that mythical single pane of glass. And let's call it mythical because chances are that it's always going to be work in progress. We're never going to fully get to the pure single pane of glass for absolutely everything. However, this is another iteration of getting you closer and closer to that reality, where you're going to be able to see seamlessly all these constructs that you have deployed around a global service mesh across multiple clouds and multiple abstractions. And that's going to make happy auditors and InfoSec people, et cetera. Now, the way TSM was implemented is quite interesting. TSM was implemented as a global controller. Essentially, think about it like an Uber control plane for distributed systems, right? That is really the secret sauce. That is the one that controls primarily all the constructs that are below that, right? That is it's a SaaS-based constructs at the moment, and it's a very, very powerful system that you can interact with, and it can evolve in a natural fashion. But you also have what's called here, if you look at the picture here, the Tanzu Service Mesh local controllers. Those are your more, cookie cutter type approach of service meshes, right? Today, we're using that based on Istio, but there is really nothing in the technology that tells you that this has to be, specific for Istio. In the future, if we see that, things evolve in a different direction or in multiple directions, there's nothing that stops us from changing or tweaking things. The important aspect is you don't control the life cycle. You don't have to care about the life cycle. I've had the chance to talk to many customers that are, sort of bitter in a certain way with service meshes because they say, yeah, well, it adds me a lot of features, but that's another thing I have to manage, another thing that I have to control the life cycle for. Well, not here. In this particular scenario, the Tanzu Service Mesh Uber control plane, the global controller, does take care of the entire life cycle of that service mesh. If something needs to be upgraded, it needs to be changed, it needs to be swapped, etc., all that happens behind the scenes. So you have to focus only on the things that you care about. And again, not having to deal with that kind of complexity. Now, because Tanzu Service Mesh gives you this multi-cloud, multi-abstraction view, it has the capability of creating new constructs, right? And one of the new constructs that were created with this product is something that we call Global Namespace. I know namespace is probably another one of those words that is somewhat overloaded these days, but hey, this is it, right? This is the name we came out. Maybe we rename it in the future for all you know. But essentially, the important thing is think about it as a horizontal slice across all your clouds and across all your abstractions. It provides this view, the sealed constructs that have very discrete inputs and outputs with its own service discovery, its own identity, its own policies, its own traffic routing, and it's typically labeled with with the DNS name as you see it here, right? So you see staging.app1.acme.com, then you have prod.app1.acme.com. That gives you a very interesting idea on how can you actually use a global namespace behind scenes. And of course, what's more important about the global namespace is that it takes pieces and constructs that belong to different abstractions. In the current implementation of our product, this is all Kubernetes clusters. But in the future, you may see components that, say, are a space in a Cloud Foundry environment, or an org, or could be a SaaS element in a Salesforce cloud, or something completely different. And you basically put them all together as constructs that you can now work with inside of this global namespace. And you can apply your own policies and how they're going to interact with each other without having to care about how is that implemented behind scenes. So if you take it one step down, if you look at it, instead of looking at it from the logical perspective, if you look at it from like the inventory view of things, right? And if you look at the clusters below, right, you would see that each one of these elements have ingress gateways and egress gateways, right? So they're all talking to each other in the background. And this actually brings some very interesting concepts to networking, right? Typically, we're very used to discrete east-west, north-south boundaries. In this case, it could be anything. I mean, it looks like in the diagram that you're doing east-west, right? Because your egress gateway is going through, point A to point B. But what if the cluster 2 is in a different cloud? Then all of a sudden, you're really doing some sort of north-south, right? You're going up, and then you're going outside the network. You're going through the internet or through a VPC, and then entering through another load balancer, through another ingress gateway, right? So there is a lot of interesting things that will start occurring once you have these constructs available for you. The important thing is that the multi-cluster aspect of this and the multi-abstraction aspect of this is really the power that you can now, as a developer, start using, right? So you don't have to worry about what's really backing it up behind scenes. You can gain additional features and capabilities that could be very, very powerful and very sophisticated. Like in this case, you can have application continuity, for example, being provided to you. Right? You can have a global namespace that you're working with, and behind scenes, transparently, the service mesh has deployments that can span regions. Like in this case, the example, you have US West and US East, right? Each one with their own, say, ingress gateways and egress gateways fronted by a global load balancer, right? There's a lot of abstraction that keeps happening. But again, you as a developer, as a consumer of this construct, you don't have to think about that. You don't have to worry about how is that implemented. You may now start dividing and conquering. You may start having some different personas that will carve out this GNSs for you, right? And then you can just come in and just use it, right? Or you can create your own GNSs based on CI/CD constructs. We're going to do an API walkthrough during the demo that Deepa will do, and you will be able to see some of these constructs and some of these calls that you can do that you can incorporate in your pipelines. Now, I was mentioning earlier that don't get too hung into the idea of judging the service mesh because of how it's implemented. A lot of folks get sort of annoyed in the concept of sidecar because they say, well, now I have 10,000 sidecars running all over and consuming a lot of memory. It doesn't matter how small they are. Well, service mesh, as I mentioned before, is really a pattern. And as a pattern, we can create optimizations later. Never fall for the premature optimization. We all know that's a bad idea in engineering. So think about what this system can actually give you. Behind scenes, some of the things that we're looking at is, for example, using Envoy directly controlled by the hypervisor in order to reach out all the way to the edge of the VMs, right? In this particular case, you wouldn't have necessarily hundreds or thousands of envoys. The hypervisor can create abstractions for you. I mean, that's one of the beauties about us being VMware now, is that essentially, we can control an entire set of the stack all the way deep into the low-level abstractions that are happening at the hypervisor layer. These are some of the ideas. And again, it doesn't even have to be Envoy per se. We can use advanced constructs like NSXALD, for example, like based on our AVI Networks acquisition. Very powerful piece of software that gives you other set of abstractions and other set of capabilities, almost linearly scalable. And we can implement it either as a VM, proxying other VMs, or directly as a function of the hypervisor. These are some of the things that we're working on. Again, this is not fully baked yet, but these are some of the things that we're currently looking at and working on. So this gives you an idea of how powerful can this set of constructs be if you use them properly? The other thing that is also extremely important for us is federation. This is something that we took very seriously from the very beginning. We know that the world doesn't operate in the vacuum. We know that you're going to have to interact and work with different service meshes or different distributed systems from different vendors. And in that regard, we spearheaded Project Hamlet. That is an open source project. I will provide a link at the end in our resources, so you can actually go see it. And one of the things that Project Hamlet does, it really is an open source specification, right? That currently gives you 2 APIs at the moment. It gives you a federated resource discovery API to authenticate and securely distribute resources through federated service meshes. But it also gives you a federated service discovery API. So you can actually reach, authenticate, and securely communicate with federated services. As you see here, the third-party service mesh in this case is considered, quote unquote, a black box. In fact, if you go to EnvoyCon, like I normally do, you see many companies out there that are creating their own service meshes with their own control planes based on Envoy itself. There's nothing would stop you from embracing this standard, this project, and making sure that you can federate with other components such as Tanzu Service Mesh or whoever else ends up adopting this in the future as well. We already have tested and demoed in previous conferences federation with Google Anthos, for example, or with HashiCorp Console Connect. It's possible to exercise federation with any sort of third-party distributed system, as long as they also support the same protocols, and they're also willing to work towards interoperability standards. So we see a future where this is going to become a very powerful capability, and you're going to be able to interoperate across multiple specifications and multiple systems. We both, as VMware, as well as Pivotal before, been part of the SMI specification as well. So there's more on that that can be addressed. Now, once you're in the data path, you can do very, very creative things, right? One of the most powerful aspects of Tanzu Service Mesh is the policy model. The policy framework that Tanzu Service Mesh implements is extremely powerful and is dynamic. That means that you as a developer can define the policies, can you define the constructs that you want even before you deploy any services. So you can say, for example, okay, this is the behavior I want under normal situations and normal constraints. And then you say, okay, if, say, my database falls below the 90th percentile of performance, for example, all of a sudden I want these other constraints to happen. And your services are going to be either part of that resource group or they're not going to be part of that group. There's going to be a continuous assessment, right? Yeah, at some point, if your performance falls below certain expectation, your service may become part of that particular group and be subject to those particular policies, right? These are end-to-end policies. They have a rich continuous capability, continuous assessment capability, and it has a very powerful pluggable engine. One of the things that we're looking at, for example, is to incorporate, say, carbon black constructs, right? Carbon black can give you a carbon black score for a service. So a service, for example, that falls below a certain percentage or below a certain number of the carbon black score may simply not be allowed to be deployed in production, right? So as you can see, these are very powerful ideas that are all being combined together and added to add more controls for new generation of applications that can be deployed faster. Ultimately, the real power of a service mesh is to be able to layer abstractions on top of each other. The kubectl apply type developer will get automatic sidecar injection. If you're a CF push developer, now you can have your entire quote unquote foundation for Cloud Foundry running inside of a global namespace, for example. You can have mutual TLS across all the components that make part of your pass. You can have a single routing tier that will support both the ingress for your pass as well as the components of the pass itself, and all that can be strongly isolated using the global namespace constructs. So this is the part that actually you're going to have more fun because you're going to get to see this, and I'll pass it along to Deepa so she can show you how this actually works.
Okay, thank you, Ramiro. So let's move along to the demo. So what you see here is the UI associated with Tanzu Service Mesh. As Ramiro mentioned, we have a global controller, and typically each tenant has their own view of their service mesh and clusters. So let me walk you through how we typically would onboard a Kubernetes cluster onto Tanzu Service Mesh. In order to do that, typically what you would do is you would go to this console, give your cluster a name. Let's call it cluster new, generate a security token. And as part of this, what you get is a YAML. And this YAML contains a few components, one being an agent that is used for us to establish a communication with our global controller, and a security token so that the cluster that you onboard is authenticated correctly with our service mesh global controller. Once this bidirectional communication channel is established, we go ahead and install Tanzu Service Mesh on the cluster. As this process completes and the connection is established, the agent starts to scrape the metrics and the Kubernetes services that are running.
Deepa, sorry to interrupt. I don't think you're sharing your screen. I think we're getting some. It's okay.
Okay, my bad. Trust me, something like that. But let's go back. So let me start again. So in order to onboard a cluster, you'd typically go through the process of creating a new cluster, applying a YAML on the cluster, and establishing a security token. And once this process is complete, you'd go on to the console. And what I did here is I've pre-created a few clusters and onboarded them onto Tanzu Service Mesh. So what you see here is two clusters. These are EKS clusters, essentially running on AWS. I have a TAS cluster over here. This is essentially Tanzu application services onboarded into TSM. And on the right-hand side, cluster, which is which I call data services, which is actually running on-prem. So the general idea, as Ramiro mentioned, was that TSM provides this global single pane view of your services running on different clusters and different clouds. And this is kind of giving you that single pane of glass where you can monitor your services and applications running in a multi-cloud environment. Typically, applications can be a single home, as in deployed on a single cluster, but you may also have an application which is built in such a way that it's partly deployed on one cluster, while maybe your data services are deployed on a different cluster. So in this specific example over here, what I've done is I've taken an application that we call Acme Fitness, and I've spread it across two clusters, EKS1 and EKS2. And let me drill into one of these clusters over here. So what you see here is part of the application, which is largely the front end and a middle tier and most of the data services deployed on EKS1, and the communication graph for that application. Similarly, on EKS2, a part of the application is deployed. So Acme Fitness is a polyglot, essentially having around 11 services. And basically, in order to achieve this communication across the two clusters, I'll walk you through how we create a global namespace. Ramiro touched upon it during his presentation. Basically, what a global namespace is 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 that it is a construct, an abstract construct which abstracts the namespace boundary from a Kubernetes cluster. So you can pick and choose your clusters on which and namespaces which you would like to onboard into a global namespace. So over here for the Acme Fitness app, I have created a global namespace and given it a domain name. And this domain name is, as you see here, .acme.com, is more a way to globally name your services. Typically, when you deploy a service on a Kubernetes cluster and try to access it, you'd access it by its cluster local name. But with this abstraction of this domain name, it's no longer tied to a cluster, but the service itself. And even if your service moves around to different environments, the name still stays strong. So you can also migrate your services to different clusters without having to change the application. After the GNS domain name is configured, what you would do is, as I mentioned, pick and choose a few namespaces which you wanna onboard onto the GNS. So here I have the default namespace on the two clusters where the application is deployed, included in this GNS. Now, this can be done from the UI as well as we have APIs available. And the important thing is that the namespace nor the cluster needs to be created in order to achieve this. You can also create these constructs later and establish the rules a priori. Here you can see the second cluster as well, and the service preview associated with cluster 2. So on EKS2, I have a couple of services, whereas on EKS1, as you saw earlier, the large portion of the application is deployed. As you define a public service, so if you want application to be exposed outside the cluster, you can do that using a public service and also tie a global GSLB policy to it for HA functionality. You can also specify which external services you want to have onboarded into your GNS. Remember, a global namespace is more like an isolated boundary. So as a application owner, you can control what services are accessed from within the cluster or outside. TLS policies. So by default, potentially you could say that I want to encrypt all my service-to-service traffic. You could also potentially have a simplistic environment where you don't want any kind of encryption. The TSM ships with global CA in our global controller. And that's how we establish the trust within the GNS for those services. Basically, the cluster level CA is an intermediate to this CA in the global controller, but you could also anchor it to your enterprise CA. That is a feature that we will be supporting in the roadmap. Once the configuration is complete, what happens is that TSM controller starts to reason about the services that are part of the global namespace and establish traffic routing rules on these clusters. And this essentially helps establish the communication between the clusters. So what you see here is the service graph across and the communication graph across the two clusters where the Acme Fitness application is deployed. Now remember that all these service-to-service communication is encrypted, as well as cross-cluster. It is encrypted. Um, let me glue into one of the services itself and show you a few things that you can see with respect to the service. Here, what you see is the spider graph and the association of the shopping service with respect to the other service it communicates with. You can have a look at its request per second, but also potentially add in P99 latency. You can also correlate your service performance with respect to the nodes it's running on. Now, what this helps with is typically a troubleshooting scenario where you're trying to understand the performance of your application. Moreover, these metrics are also available through APIs, and we integrate with some other scaling solutions in order to scale out your application based on policy as well. Similarly, you can have a look at the service and service instances that are deployed on with respect to shopping. Let me show you also the infrastructure view where you could potentially look at your node metrics and the services associated with them. And going back here, you can also have a global view of your metrics. So on top over here, this is a more fleet-wide view of the metrics associated with your Tanzu Service Mesh controller. You could also add a few other golden metrics and have an overall view of the performance of your service mesh. Let me start to walk you through a few other use cases that are possible with CSM. So one of the things that Ramiro mentioned was that Tanzu Service Mesh supports dynamic access control policy model. So what I've done here is taken the same Acme Fitness app and defined a few resource groups. By resource group, what I mean is that it's a construct which allows you to map certain services into a group and reason about those groups. So over here, I've kind of split the Acme Fitness app into 3 tiers. The front end, which includes shopping, the back end, which includes a few other services, and tier for the middle tier services. Now, basically, with this grouping construct, what you can do is take these groups and start to define access control policies. For example, as a use case, you might want your front end services to only talk to middle tier, and your middle tier services only to talk to the back end. So similarly, you can define such policies as well. As an just visualizing how this would look. As an example, I have a deny all policy for the front end to talk directly to the database, but the middle tier will be allowed to talk to the database services. If you want to visualize this view, you can potentially also have a look at the access control policies. Now, the other thing that you can also do is you can have a look at the access control policies from the point of view of visualizing it. So here I have a visual map of my access control policies where basically there is the front end services trying to access the, let me just refresh this. Yeah, so this looks better. So to visualize, you can see that the backend services has the ability to only talk to the middle tier, and the front end services cannot talk to the backend. Similarly, you can also, we have integrations with third-party vendors as well, where you could attach risk scores to your services and moreover, use those scores to allow and deny policies as well. Another use case that I wanted to talk about is progressive upgrades. So as part of TSM, you can also uh, uh, progressively upgrade your application um, uh, service by service. So for example, if you have a certain version of your card service that you want to potentially upgrade, you could version test that service, make sure that it is up and running from a performance point of view, and then put in a request for that service to be upgraded. So that's a possibility as well with TSM. Let me walk you through another use case at this point. And this is something that is still a little bit of work in progress, and we're just starting to bring this together. But see here, what I have here is a TAS cluster, which is the Tanzu application service running on Kubernetes. As Ramiro mentioned, many developers like the CF push experience that TAS provides, whereas the combination of TAS and TSM brings in a comprehensive solution of providing all the service mesh capabilities for TAS applications along the lines of security, connectivity, as well as discovery. So kind of gluing into the service graph. So here, Tanzu Service Mesh is forming this substrate for the task at the layer of service mesh. And here you see that it's established a communication graph for all the control plane services running in TAS. Again, all this the traffic is all encrypted. I'm going to go ahead and push an application in CF and walk you through a few other things that you can see. So let's just go ahead, and I have an application called Spring Music here, which I'm going to go and deploy on a task cluster. This takes a few seconds. While that is going on, I can also I wanted to also indicate that I have created a global name for this application called and give it a domain name of Spring Music here, which will allow me to also define some communication patterns with data services that could potentially be running outside. Let's see, the app is still being deployed. As being deployed, let's have a look at the service graph. Right now, you start to see that some of the patterns would change here. Okay, a few more minutes and it should be up and running. So yeah, what's happening in the backend is that the application is being built and deployed to the task cluster, and a route will be established as well. And the ingress layer of TAS uses the Istio ingress controller, ingress gateway, which is controlled by TSM in this specific demo. Now, the app has been deployed, and let's have a look at the route associated with the app and try to get to it. There we go. And there we are. So the app is accessible. Now, basically what you will start to see here is that the graph would change. And as you can see, some more services are starting to communicate with each other. Similarly, you will also see in a bit that the Spring Music app is being accessed by from the Istio Ingress Gateway as well. It takes a few seconds. Okay, there we go. Here it is. As I mentioned, here what you see is that I was trying to access the service from the Ingress Gateway, and the communication has been established with it. As I mentioned, I had created another workspace, another global namespace for CF workloads. And here, for that application, you can also see the global namespace associated with it. Now, similar to how I had defined policies for the Acme Fitness app, I could potentially also define some policies for the Spring Music app as well, or define the progressive rollout progressive rollout migration strategy for my application as well, for my globe base. So there was one more thing that I wanted to kind of go towards, and basically what you see over here is I have a cluster which I call data services, where I have a MySQL service deployed. And let's just have a look at that. And what you see here is the MySQL service. And basically, this service is part of the same global namespace as where the Spring Music application is deployed. You can potentially do is that you can user-defined service here, where you can specify the name associated with the MySQL service running on data services and access it from Spring Music. So you establish communication between service running on a different cluster, an application running in the TAS. And TSM takes care of the routing as well as the service discovery associated with this application seamlessly. On top of that, even the service-to-service communication is encrypted through the Envoy proxies that are running as sidecars alongside these applications. So let me go ahead and deploy it. And let me restart Spring Music. And with that, basically, what would end up happening is that Spring Music would start to access the services running in the MySQL database externally on the data services cluster. As you can see, it was very simple to to do that. Developers don't need to configure any DNS or any specific encryption or policy. I mean, any this enterprise CA. This is all taken care of by TSM as part of the orchestration. So I think lastly we wanted to go through the APIs. So let me kind of quickly go through what we have available in terms of APIs. So whatever I showed you from the UI is all also possible from the API. So here you can have a look at the API Explorer. And let me just go over the global namespace APIs and run through one of them. So potentially what you can do is you can get all the global namespaces associated with TSM service. And let me go ahead and execute on it. And essentially this returns to you that I have two DNSs deployed. One is Acme Fitness and one is CFO Clothes, as you saw earlier. Similarly, there are APIs available to create public services. There are APIs to create your HA policies and also deploy your clusters and your ACP or your resource groups. I think with that, I am pretty much done with my demo. Ramiro, I'll hand it back to you.
Thank you, Deepa. I appreciate that. I think we're at time, but on behalf of Deepa and I wanted to thank you for your attention here and your time. This is going to be recorded. I'm going to post the slides as well. I apologize for there's a little confidential logo on the bottom of the slide. That's not correct. That's just the template. I need to modify that before we upload them. In addition to that, keep monitoring the channel. I'm going to jump into the Q&A as soon as we're finished here. Okay. Thanks again. I appreciate it.
Thank you so much for that. And that was a really great way to end this conference. If you have questions, I assume that there is a Q&A after this, so feel free to head over there. And thanks everyone for attending.